What is motion? The change in position or orientation of an object with respect to a reference point over a given time. What is two-dimensional motion? When an object moves along two different directions simultaneously. Imagine an object moving in both the horizontal, x-axis, and vertical, y-axis, directions. What is speed? It is defined as the total path length, i.e. actual distance covered, divided by total time taken by the object, i.e. speed is a scalar quantity. It gives no idea about the direction of motion of the object. Hence, speed of the object can be zero or positive but never negative. Speed equals total length traveled by total time taken. What is velocity? It is defined as the ratio of displacement and the corresponding time interval taken by the object. Velocity equals displacement by total time taken. What is the difference between distance and displacement? Displacement is the shortest distance between any 2 points, whereas distance can be any path that connects any two points. So, for any 2 points it contains only one displacement and infinite distances. Relative motion. If the velocity of two bodies are known WRT, a common frame of reference, then the velocity of one of the two bodies can be measured WRT, the second body. What is acceleration? Acceleration is the rate of change of an object's velocity over time. In simpler terms, it's how quickly an object's speed or direction is changing. Acceleration can be positive, speeding up, or negative, slowing down. There are two types of acceleration: uniform and non-uniform. Uniform acceleration refers to the motion of an object where its velocity increases at a constant rate in equal intervals of time. In simpler terms, the object's speed picks up consistently over time. X. Riding a bicycle in flat road. Non-uniform acceleration is the opposite of uniform acceleration. It occurs when an object's velocity changes at different rates over time. This means the object's speed can be increasing or decreasing, but not at a constant rate. X. Riding bicycle in slanting road. What is free fall? An important example of a straight-line motion with constant acceleration is that of an object rising or falling freely near the Earth's surface. Near Earth's surface, g equals 9.8 ms². Formulas obtaining acceleration. F equals ma. S equals ut plus 0.5 at superscript 2. V equals u plus at. V superscript 2 u superscript 2 equals 2 as d superscript 2x slash dt superscript 2 equals dv slash dt equals a. Some special cases. If an object starts from rest and moves with a uniform acceleration, then displacement covered by it in time t is directly proportional to t superscript 2, i.e. s is proportional to t superscript 2, and if a body starts from rest and moves with a uniform acceleration, then displacement covered by it in successive seconds will be in the ratio of odd natural number, i.e. s superscript 1 s superscript 2, s superscript 3 equals 1:3:5. When particle covers 1/3 distance at speed v1, next 1/3 at speed v2 and last 1/3 at speed v3, then VAV equals 3 v1, v2, v3, by v1, v2, plus v2, v3, plus v1, v3. If a particle is accelerated for time t1 with acceleration a1 and for time t2 with acceleration a2, then average acceleration is AVG equals a1, t1, plus a2, t2, by t1 plus t2. Projectile motion. H max, velocity of y component is 0. R max, maximum distance that a projectile motion can cover. Time of flight. It is defined as the total time for which the projectile remains in air. T equals 2 U by g theta angle subtended BTW x and y axis. Maximum height. It is defined as the maximum vertical distance covered by projectile. H equals U superscript 2 sin superscript 2 theta by 2g. Horizontal range. It is defined as the maximum distance covered in horizontal distance. R equals U superscript 2 sin 2 theta by g. Note, horizontal range is maximum when it is thrown at an angle of 45 degrees from the horizontal R. Max equals U/g. For angle of projection theta and 90 degrees theta, the horizontal range is same. If an object is moving with uniform acceleration, then instantaneous acceleration equals uniform acceleration equals average acceleration. Graphs, distance versus time. Velocity versus time. Acceleration versus time. What is circular motion? A circular motion, particles move along circular track such that direction of motion changes continuously, unlike in a linear motion. Terms related to circular motion. Angular displacement. It is defined as the angle turned by the particle from some reference line. Angular displacement theta is usually measured in radian. Finite angular displacement theta is a scalar, but an infinitesimally small displacement is a vector. Angular velocity. It is defined as the rate of change of the angular displacement of the body. It is an axial vector whose direction is given by the right-hand rule. Its unit is rad/s. Angular acceleration. It is the rate of change of angular velocity. Its unit is rad superscript 2/s. Centripetal acceleration. Which is the component of a towards the center of the circular motion. This is responsible for a change in the direction of velocity. Centripetal force. A particle performing circular motion is acted upon by a force directed along the radius towards the center of the circle. This force is called the centripetal force. If m is the mass of the particle, then the magnitude of centripetal force is given by centripetal force equals mass * centripetal acceleration. Centrifugal force. It can be defined as the radially directed outward force acting on a body in circular motion, as observed by a person moving with the body. Then centrifugal force is given by centrifugal force equals mass * centrifugal acceleration. Centripetal acceleration equals centrifugal acceleration, as per formulas.